The mathematical engine of antisymmetry and orthogonality serves as a universal foundation for navigating complex dimensions, functioning as a perfectly sensitive system that flips its output upon swapping inputs. This inherent rigor ensures that if any two inputs are identical, they cancel out, allowing the engine to produce a single, unique direction that remains perfectly perpendicular to its components. This mechanism provides a generalized way to find the normal direction, the ultimate up, across any number of dimensions. In the realm of higher dimensional calculus, this engine becomes a vital flux carrier for exploring manifolds. By identifying the tangent vectors that lie flat against the surface, the engine generates a normal vector that points directly away from it. This orientation is essential for calculating flux. It defines the boundary of a space and determines how much of a flow, such as wind or a force field, is actually passing through a surface rather than merely sliding along its face. This geometric utility extends into the four-dimensional world of general relativity, where the engine acts as a geometrical bridge between seemingly distinct forces. It reveals that electricity and magnetism are not separate entities but rather orthogonal rotations of one another. By applying this engine to the electromagnetic field, the roles of electric and magnetic components are swapped, revealing a deep natural symmetry. This mathematical elegance collapses four complex Maxwell equations into two simple geometric truths, demonstrating that laws like the absence of magnetic monopoles are essentially the orthogonal versions of laws like induction. Practically, these abstract concepts manifest as a dynamic escape property. Visualizations of this process show a normal vector adjusting in real time, maintaining its perpendicularity even as a surface tilts and twists. In physics, this results in a role reversal, where the electrical source in one frame becomes the magnetic component in another. These tools ultimately prove that while the mathematical lens may shift, the underlying shape of physical reality remains consistent, elegantly unified, and geometrically sound.